Hey, Corinne, drop the ball.
I
did Mr. Hahn have?
I would say that was the highlight of my day.
Oh, thank you.
highlight of my day was lunch.
Yeah, me too.
Yeah, that was my highlight. When I got to sit.
My highlight was not getting hit in the which is
Actually, didn't get hit in the face today, so that's good.
I did, and I was like,
I only got hit once, and that was but
yeah, I got hit twice. One in the ear / face, and then one in the thigh.
Okay, right.
ear
Jot this down, please. The direct variation equation is this. This is what you should have as the first thing in your notes, and we'll refer back to it and talk about it later. This is one of those things in math which is really the same as something else, but they just call something different. I think just to confuse everybody. I don't know why. What direct variation is, first of all, what, Gwen, does it mean to variate? Yes, to change would be a good answer to that there. And direct variation means this, as opposed to indirect variation, which we'll throw in there a little bit. Something varies directly, it means simply this. Okay, as one thing goes up, comma, so does the other. Okay, as one thing goes up, so does the other. An example of that would be if you have a job. A job is a pretty good example of direct variation because the more hours you work, somebody want to finish that?
The more you get paid.
The more you get paid. For example, if you have a job that pays $8 an hour, if you work 0 hours, you get paid $0. If you work 1 hour, you get $8. If you work 3 hours, you get $24, and so on and so on and so on. That is direct variation. Okay? And there's a couple things that have to happen for things to be direct variation. Number one, this has to be true. Okay, that 0 equals 0. Okay, it has to, if you graph it, it has to start at the origin. Does that sound familiar to anything else we've done before?
Yeah, X, Y, and
Starts at the origin, it's going to be a straight line, and it is very much the same as being proportional. Okay. Now think about it. What would be an example? Indirect variation is the opposite, which means as something goes up, the thing goes down. Now can you think of something that's indirect variation? As the more you eat, the less food you have. That actually would be true there. Any other examples of that?
The more you eat,
the farther you go, the less gas in your car.
Yes. The amount of gas in your car is indirectly proportional to the distance you go. In the same way, that the faster you go, the lower your gas mileage. Those would be indirectly proportional. The less happy you are.
Yeah.
The less time you get to play basketball. I understand that, okay? Now, here is the deal with this equation here. The biggest part of that equation there is that letter K. The letter K right there is what's called the, yeah, it is not Katie. It is called the constant of variation.
So should we start with the C?
No, we already have C. C in math is taken up with the formula E equals mc squared. C is what? The speed of light. When you see the letter C in math, it's reserved for talking about the speed of light. Not that it can't appear in other places, but you know, and that's set like that. Just like slope is the letter M, generally speaking. The letter K is the constant of variation. Okay, and going back to this thing right here, what is my constant of variation? It is what you multiply by to get the other number. Okay, what factor do you multiply? Here, what was my constant of variation here was, what times what gave me that? 8. So the equation, the direct variation equation of that is y equals 8x. And this is very much like writing in slope-intercept form, except for something to be direct variation, it'd have to have the y-intercept is always going to be 0 because it has to go through the origin. So y equals 8x is your thing. Let's see what else they ask us about that. Like I said, it's something that you do before. Other ways that you can write this would be, what is this? Y equals kx. I'll jot this down here. Let's be like that. Y equals kx. If I were solving for the letter k, what would I get rid of on this side over here? How do I do that? I would divide by x. So another formula that also is the same thing as that is this. Divide by x, divide by x. K equals y over x. Okay, that's another important one to remember. To find the constant of variation, you take the letter y and divide it by x, and that will tell you the number that you stick in for right here. So like an example would be, let's see here, from the book it asks you, this one here, write these 3 points down. 2 comma negative 14, 5 comma negative 35. Is this one of those little jingle things?
Probably.
Negative 3 positive 21.
She probably knows that we're doing math.
She probably knows that.
What's our test? Wait,
Now-
negative 3 comma 21?
The question the book asks is this direct variation? So, the question, in order for something to be direct variation, what would have to happen?
Straight line.
Straight line starting
Straight
in the
line,
origin.
so the origin has to be flat.
Okay, but instead of having to graph this, how do I know if this is direct variation or not? Think about your formula. Y equals k, I'm sorry, y equals kx. If I take one of these points, children, and put it in for y and k, or y and x, what do I have here? Y is negative 14, x is, what's x? 2. What does k equal? Okay, the constant of variation would have to be negative 7, which means this. In order for this to be direct variation, you have to get a negative 7 for all the other points as well when you do that. Or just say to yourself, if I multiply 2 times negative 7, do I get the same thing here? If I multiply 5 by negative 7, do I get this? If I multiply negative 3 by negative 7, do I get that?
Yes.
Yes, and if so, then yes, this is, yes, it is direct variation. And the constant of proportionality or direct variation is negative 7. If you did graph that, would it go through 0? It absolutely would. Because this, if it's true for these that they have the same constant of variation, then it's going to go through 0 because 0 times negative 7 is going to give you 0. I can tell you're intrigued by all that. How about this one? 2, 4, 3, 5, 5, 7. 2, 4, 3, 5, 5, 7. Okay, to sum this up quickly, all you need to do is look at the x and say, what do I do with x to get y? What do I multiply by?
2.
2. Now, does that hold true for every point here?
No.
If you multiply this times 2, you get 4. If you multiply this times 2, you get 6. Once that's not true, then it doesn't have, it's not proportional, it's not direct variation because it has to be the same constant of proportionality or direct variation.
No.
So this would be a big
Fat. No.
no on that. Don't use the word fat.
Why?
Discard me.
You're not
How about this? Y minus 12 equals x. If I asked you if that was direct variation, yes or no?
A big skinny. A big normal.
Remember the equation for direct variation has to look like this. Y equals k times x. Nowhere in that equation do you see an addition or a subtraction sign. If you see an addition or subtraction sign in your equation, it can't be direct variation because this line will never go through the origin. Because if we were graphing this, what would I do? If I move that 12 to the other side, it becomes y equals x plus 12. You know that this crosses the y-axis at 12. So the only way for something to be direct variation is for there not to be an addition or subtraction number.
So it's a no already.
So this is a no. Okay? Otherwise, if something doesn't have those things, well, let's look at a couple other examples, I suppose. What about this one? Because they throw it a little different way. Y over negative 3. Y over negative 3 equals x. The question is, can you write this in the form of y equals kx? Can you change it so that it would look like that? Yes or no? What would you do, Steph?
You multiply both sides.
Multiply both sides by negative 3. You're going to get y equals a negative 3x. And as long as you end up with a number in front of x, your constant proportionality will be negative 3. What about this one? 2xy equals 8. Can you change that so that it is in the form of y equals kx? Well, how do I get the letter y by itself? I divide by 2x. What happens when I divide this by 2x? What am I left with? Y equals, no, 4 over x. And there's nothing that you can do with this x that will put it over here like this. Okay, the x cannot be on the bottom of the fraction. If it was on top, you'd be fine. But on the bottom, no. This is actually an example of indirect variation. That one will go up, the other one will go down. So this is another no as far as that would go. Can I help?
What if you multiply it by 4?
If I multiply this by 4?
Well, like, now you like go 4 and then cross it out.
Wait, am I back at am I at this point right here?
Yeah.
If I'm at y equals 4 over x, and I'm multiplying what by 4?
No, like 1 over 4.
If I multiply by 1 over 4, these cross up, but the x is still on the bottom. So I end up actually with 4y equals that. Okay, and you can't have an x on the x on the bottom will never give you direct variation. It'll be indirect variation. It'll be the opposite because one goes up and goes down, sort of thing. How about 3y equals x? Direct variation or no? Remember, you need it to be solved for y. It needs to be y equals kx. What would you have to do there? Divide by 3, but you end up with x over 3. But what is x over 3? It's the same thing as y equals 1/3 x. And the constant of proportionality would be 1/3. The big letter K. Wasn't that more exciting than you really thought it would be at the beginning of the day?
Honestly, yes.
Really, Glenn?
Yes.
Me too.
I thought it was going to be a lot more boring than that.
well.
That was
We had to accommodate.
Yeah.
I was gonna say.
Look at page 365, please. Testing is over.